Hi everyone, I am Madam Osmaya. In this video, we are going to discuss on derivation of velocity v in simple harmonic motion and graph v against x. First, we are going to derive the velocity v in simple harmonic motion. If the object move in simple harmonic motion, the acceleration of the object is equals to the negative omega squared x, where omega is the angular frequency, x is the displacement. So A acceleration is equals to dv by dt. So the dv by dt we can expand becomes dv by dx times dx by dt. When we cancel the dx, we can get back the dv by dt. So we don't change the equation above. So dx by dt is equals to v. So the equation becomes v dv by dx equals to negative omega squared x. Then we separate the variables v and x, left and right side. So cross multiply dx. So the v dv equals to negative omega squared x dx. Then we integrate both sides. So for v, we get v squared per 2. And for the integration of negative omega squared x with respect to x, omega is constant, so we get negative omega squared, so x squared per 2. Then plus c, the constants. Next, we are going to determine the constant c. So when x equals to x naught is the maximum displacement, and v is equals to 0. So we are going to substitute these two values in the equation here to determine the constant c. So v equals to 0, so this term becomes 0. Then negative omega squared x, so we substitute x naught into x, we get negative omega squared, x naught squared per 2, then plus c. So we rearrange this expression, becomes c equals to omega squared x naught squared per 2. So this is constant c. Now we rewrite the expression here, becomes v squared per 2 equals to negative omega squared x squared per 2, then plus the c is omega squared x naught squared per 2. So cancel out all the 2, the expression become v squared equals to negative omega squared x squared plus omega squared x naught squared. Then v equals to square root of negative omega squared x squared plus omega squared x naught squared. So we can simplify, becomes plus minus omega square root of x naught squared minus x squared. So this is the velocity if the object move in simple harmonic motion. So we have derived the velocity in simple harmonic motion. Okay, then from this equation, we can plot the graph v against x. So the object move in simple harmonic motion. The velocity is given by plus minus omega square root of x naught squared minus x squared. So the shape of the graph is a ellipse shape. So for the object move in simple harmonic motion, fixed point is 0. So to sketch the graph, when x is 0, so we substitute here 0, so we get maximum velocity omega x naught squared, and the minimum velocity negative omega x naught. X naught is a amplitude or maximum displacement. So we try one example. A particle performs simple harmonic motion with an amplitude of 0.50 centimeter and a period of 3.0 seconds. Calculate the angular frequency of the simple harmonic motion. And B, the velocities of the particle when its displacement is 0.20 centimeter. And explain why there are two velocities. Okay, the first question to find the angular velocity. So angular velocity omega equals to 2 pi f and f is 1 per t. So the period we can substitute this value 3.0 second. So the solution is omega equals to 2 pi per t. So substitute the period 3 second into the equation. Therefore, angular frequency is 2.09 radian per second. And to find the velocity, we use the equation just now. We derive, which is v equals to plus minus omega square root of x naught squared minus x squared. So the displacement 0.20 centimeter and the omega v is 2.09 radian per second. And this angular frequency 2.09 radian per second. So we can calculate the velocity. And then the maximum, the amplitude x naught is 0.50 centimeter. Okay, so now we substitute all the values. So we get velocity plus minus 0.958 centimeter per second. So we have two values. If v equals to positive 0.958 centimeter per second, this is when the particle is moving in the positive direction. And when v equals to negative 0.958 centimeter per second, this is the velocity when the particle passes through the same point in the opposite direction of the return journey. Okay, so that's all for this video. Thank you for watching.